Hi there, hope you're well. So I made a guide rail hinge out of plywood for my DIY workshop MFT, and I gotta say I couldn't be happier with it. It's working out really well and it's doing all the things that I wanted it to do. Now, I'm a big fan of guide rail hinges. I've talked about the existing 3 commercial guide rail hinges before, and I did think that this 10-minute workshop DIY hinge might become the next in line of 10-minute workshop products. I haven't discounted that completely, but for now it is a set of plans, and those plans are available in my Etsy store now at 10minute.shop. Plans have all dimensions on them, as well as full-size drawings to make marking out the drilling positions really easy, because you do need to be fairly precise when you're making this guide rail hinge. There's 2 sets of plans available. I'll talk about those a little bit later on. So these 3 commercial hinges, the new Bench Dogs quad hinge, the dashboard hinge, and the Festool OEM hinge, these 3 hinges are all excellent. They're well made, they're well engineered, and they each have a slightly different approach to the business of swinging your rail out of the way to clear your bench top, and they all continue or build on the story, the narrative, if you like, of the original Festool MFT or multi-function table as a portable workbench. If it's portable, it stands to reason then you can move it around, you can pick up one end of it and drag it, you can get access to all sides of it. I can't do that with my MFT. This is a workshop MFT. My MFT is hard up against a wall, which means that getting access to things like height adjustment to the other side of the hinge, well, that's really awkward to do. And it's one of the things that really put me off changing the height of the hinge when I had my original Festool MFT. One of the other slight concerns too, slight niggles, is the amount of overhang, the amount of reach behind the bench that these hinges have. The Festool one has a commendable 100mm or so, but the dashboard one has almost double that, 190 odd. The Bench Dogs one a little bit less. So I want as minimum overhang as possible so that I can push the bench back further up against the wall. Now, you're never going to get rid of the overhang completely, because fairly obviously the deepest part of the cut is going to be in the middle of the blade, so you've got to accommodate everything forward of that. But around about 100mm, 120mm is about what we should be aiming for, and that's what I've achieved with my DIY hinge. And the other thing that I really wanted was full width rail support, especially on the front rail support. The Festool one in particular doesn't offer that, and it gets a little bit tippy at the front. And the other thing on the front rail support was I wanted it to be able to drop down right out of the way below the level of the bench. That reduces the need to remove that front rail support if it's completely out of the way like that. So let me just walk you through the hinge design in general. There are 12 components to the whole hinge, 4 of which are common between the front and rear parts. You've got the body, you've got the riser in each one, and you've got a couple of battens or spacers that hold that riser in place and that the riser runs against. And the main difference between them is how they're actually secured. On the front support, the riser is held in place by a T-bolt and a knob in a slot. It's easy to loosen off and drop down out of the way. There's also an 8mm dowel in the front riser to locate the guide rail. The rear riser is basically a friction fit held in place by a 6mm cover piece that's simply nailed or glued onto the spacers, and it's shaped to reach as high as possible up the riser to provide as much support as possible without fouling the hinge pivot. The hinge riser is notched on either side to take the hinge pivots, and the rail platform is held onto the pivots with a pair of steel dowel pins drilled in through the sides. When I was going through the prototyping process, I looked at all kinds of different ways of making these pivots, and while they all worked perfectly adequately, these were by far the simplest to put together. And I'd like to thank 10-Minute Workshop Plus member Richard Layton for his help on this particular aspect of the design. The rail attaches to the hinge plate that's also drilled to take M6 countersunk machine screws, and the rail is secured to that with a flat bar. I'm using a 3D printed one from friend of the channel, Stu Parker. It's the same dimensions as the Festool OEM one, just a little bit cheaper and much faster to ship. If you've got any metalworking skills, then you can make up one of your own, or you could adapt an existing rail joining bar to suit. But the drilling positions marked on the plans are for the Festool OEM dimensions, and it's probably worth checking the one that you have against the plans before drilling your holes. Construction of the hinge is really very straightforward. The whole thing's made from 12mm birch ply, apart from the little capping piece, and most of the cuts can be made with a track saw. You've got a track saw, right? Also, I've used a handsaw, a bandsaw, a jigsaw, a chop saw. The only twiddly bits that I came across really that needed some care taking over them with the actual hinge pivots. These are quite small and they certainly need to be drilled quite precisely, and I am looking at having these specific parts CNC'd, so I'll keep you posted on that one. Let me know in the comments if that's something that you might be interested in purchasing. I'd probably do a bundle of a pair of pivots with the dowel pins and maybe a couple of clevis pins too. More on those a little bit later on. The dimensions are actually largely dictated by the guide rail and your MFT bench. If you want full width rail support like I do, then the risers have to be around about 180mm wide for the standard Festool and Makita pattern rails. The spacer battens need to be about 15 to 20mm wide, and you need a bit of space in the wings for the knobs to attach to, and you want the height to be a little bit less than the height of your bench surround, so that dictates the overall size. So I've used 12mm birch ply throughout, mostly because it just looks nice on video, and the same with the swoopy curved shape of the wings. Most of my prototypes though were made from 12mm MDF, and they're holding up just fine. If you didn't want the curved wings, then a straightforward T-shape with the corners knocked off, something like this, would work. And remember, plans are just there as a starting point for you to adapt to suit your needs. The riser needs to be a nice snug fit between the spacer battens, not too tight, not too loose, and I sanded the bottom edge of the hinge riser and the top edge of the capping piece before assembly, just to make them easier to refit when they're on the other side of the bench. During the prototyping stages, I fitted the spacer battens to the body with nails, with glue, and with double-sided tape. That was the one I took to make a central, and they've all worked perfectly, so use whatever works for you. And similarly, if you've got a router, then that's the ideal tool to use for cutting the slot in the front riser, but I've also done it by drilling a couple of holes and taking out the waste between them with a plunge saw. Do whatever works for you, just remember to clamp that workpiece down first. Front and rear bodies are designed to fit immediately below a standard 18mm MFT top, and you'll need to offer them up and mark the centre of the T-track to drill out the holes for the fixing bolts. I've used regular M8 T-bolts and 32mm open or through knobs to fix the bodies onto the bench. Bear in mind that I can't mark this position on the plans because I've got no idea where your T-track is on your bench, so some audience participation is required at this stage. Now, the hinged riser works pretty well as a friction fit, and it will self-adjust to different material, but I do want to be able to lock it off for common thicknesses, and I've done that with a simple set of holes drilled into the front face of the riser that takes a 5mm clevis pin that stops the hinge from dropping down any lower. Because I'm using a pin with a head, I've used my track saw to cut a tiny rebate in the hinge body to accommodate the head and allow the pin to sit flush. I've drilled holes for 6, 12, 18 and 24mm, as these are the most common thicknesses that I'm likely to cut on this bench, but again, you can adapt this to suit your needs. So if you find yourself using a lot of 9mm or 15mm boards, then you can easily add in those positions. Similarly, I've used a 5mm clevis pin because I've got loads of them. If you want to use, say, a 6mm dowel, then go for it. Just remember that it's easier to add and remove a pin with a head, especially if you're reaching across your bench to do it. And if you do use a different size, then just remember that the positions marked on the plans will need to change slightly because they're referenced off the bottom of the pin, not the center. One final thing I've done with the front body is to drill an extra 8mm hole on the inside face in line with the fixing hole, but a little further over, closer to the edge, and I fitted a cut down dowel into that hole. You'll see why in just a sec. So with the front and rear parts located in their T-tracks on either side of the bench, the rail can be squared up against the column of holes in the usual way and the hinge body locked off. With the rail held square, I can line up the front rail support, mark the position of the under rail T-slot, and then drill out an 8mm hole for the locating dowel. An 8mm dowel will be a little bit loose in the rail T-slot, but a couple of turns of tape will sort that out and is easily replaced if and when it wears. Obviously, if you're using a different rail, you may need to change that dowel size to suit. With the rail square and the front and rear supports locked off, I can slide a stop, just a piece of 6mm plywood with a dry fitted grub screw, up against the dowel that we just fitted in the front body and lock that off. Now, if we ever need to remove the front support, we can get it back into position without needing to re-square the rail. And that's pretty much all there is to it. In use, the hinge can easily self-adjust to different thicknesses of material, or you can lock it off at a set depth, and the whole rail hinge riser assembly can be removed if it ever needs attention, like replacing a splinter guard or changing to a longer rail if, like me, you've got a front extension to your MFT bench. And all of those controls are accessible from the front. Now, I mentioned earlier on that there's a slight drawback to the full width front rail support, and that's when you're making bevel cuts. Fairly obviously, with a full width rail support, a bevel cut that runs the full depth of the bench front to back might just nick that front rail support a little bit. There's no easy solution to that other than to make the cut a little bit shorter or use my bench extension, but the reality is that I make very few cuts like this, so it's not really an issue for me. And if it's an issue for you, then perhaps one of the commercial rail hinges might be a better bet. For me though, this is working out really well. It's easy and cheap to make. I've used about 1/10 of a sheet of plywood, or you can just make one out of whatever bits of scrap you've got. And I've had absolutely no issues with it whatsoever. Now, as I said earlier on, there are 2 sets of plans available in my Etsy now at 10minute.shop. A plain set of plans, as usual, with all the dimensions, full instructions, and a full set of printable versions to help you easily mark out those drilling positions. And there's a Plans Plus version 2, the same set of plans, but with a detailed step-by-step build video included that takes you through each stage of the process. That one's a couple of quid more expensive. But I'll call this one done for now. Thanks so much for taking a look, and thanks, as always, to the channel members, Patreon, YouTube, and the new 10 Minute Workshop Plus member platform for their amazing support. I really appreciate the comments and the feedback, the conversations that we have that help form these public-facing videos and the products that we make. That's it for this one, though. Thanks for stopping by, and I'll see you in the next one.